So, example 1, solve these two equations. So you need to make them into an augmented matrix. So you put the numbers out the front of the variables.
Wait, is this what we've been doing?
Yep. So we've got the A matrix that you're used to. And then we put, what's that matrix? B, yep. So there's no X matrix. Okay? So we want to turn this matrix on the matrix on the side of the line, on the left side of the line. We want to turn it into a, kind of looks like an identity. So all the ones in the diagonal, and so we want to get it so it looks like something like this. Okay? So we have these things called row operations, okay? So row operations, you can either times a row by a scalar. So row 1, what would we times it by to get this number to 1?
1/4.
So we just use fractions. So 1/4. Okay, so this tells the person reading it, row 1, you've times row 1 by 1/4. So all the things in row 1 you times by 1/4. So we've got 1, what does the 8 become?
2.
And what does the 24 become?
6.
So the other thing you can do for row operations is you can add or minus rows away from another row. So we're changing row 2, so that's the one we're changing. So we're going to do row 2 plus 3 times row 1. Yep, so this becomes 0. Now we've got 3 times 2 plus 1. That becomes
7.
7. Does that make sense? 1 plus 3 times 2.
And you times by 1/7.
Are you okay? Hayden. 3 times 6, what's that? Row 2 times a 7th. So row 1 stays the same. This becomes a 1. 35 has given us something. What does this tell us, does anyone think? Any guesses? What does the second row tell us?
Y equals 5.
Very good.
Oh, the top one's X.
So this tells us y equals 5. How could we find x?
You just sub y into the original equation.
Yep. Or you can also use another row operation and make this a 0. That also gives you x. So either way looks easier. Subbing in y equals 5. Probably good to justify. What was that equal to? 17. So negative 3x equals 12, x equals negative 4. Okay? We could have also done row 1 minus 2 times row 2, and that would have made it 0, 0 like that, and it would have made it negative 4. Okay, so 2 different ways to do it, but you get the same answer.
And that's the next step.
And you get the same amount of marks. Probably good to say, therefore, y equals 5, x equals 4, negative 4. Entered matrix, the identity on this side, okay? And we eventually want to get the identity on this side, and this new matrix here will be the inverse.
Oh, that's gonna take a long time.
Row 2. What are we going to do to row 2? Minus, no, we want 0 here.
Oh, minus row 1.
Just minus row 1. Nice. To save time, let's do 2 row operations. So I'm going to go down again. What are we going to do to row 3? It's got a 3 there. I want to make it a 0. So I could minus what away? No idea?
3 times root 3. Wait, what? Whoa. Sorry, I'm looking at
3 times row 1. Yeah? So 1 times 3, taking it away from 3 is 0. 4 times 3 is 12. That becomes negative 6. 0 times 3, that's 0. Negative 3, 0, 1. 3 of row 2. 0 minus 3 times 1. 1 minus 3 times 0. What are we going to multiply it by? Okay, and now we've got the last row